Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Maths B. In the previous sessions, we have started the locus, transformation of axes, straight lines and pair of straight lines. With the continuation of that 2D coordinate system, today we are going to start a 3D coordinate system. What do you mean by the term 3D? Right? We have seen the two different coordinates, that is x coordinate and the y coordinate. Actually they belong to a popular coordinate system that is called as a Cartesian coordinate system, or it is also called as rectangular coordinate system. Why it is called as rectangular coordinate system? Because we used to have only a x axis and only a y axis, right? For example, if I want to point a particular point, that is x comma y, it will be at a distance of x from y axis and it is at a distance of y from x axis, isn't it? That is what we learned, right? Yes or no? Which means this forms a rectangle. That's why it is actually called as a rectangular coordinate system, right? If I place a third coordinate system which is perpendicular to this, which means like this, right? We cannot realize on a board, but this is in the direction of x, this in the direction of y, and the third thing which passes through both of them and perpendicular to both of them, right? Is this y axis and this z axis are perpendicular to each other? Yes, they are. And this x axis and this z axis are perpendicular to each other? Yes, they are. Which means all three coordinate systems are all three coordinate axes are perpendicular to each other. Is it clear? Or else let me realize, for example, see here, this is our cuboid, right? Which means this textbook has three dimensions, that is, this is x axis, right? And this perpendicular thing is y axis, and the thing which is perpendicular both of them is z axis, okay? Which means whatever we want to place, we will write it as something in diagrammatically we will write it like this, okay? This middle one is nothing but our z axis. If this is x, this is y, and that will be our z axis. Then here in the previous cases we used to have only x and y coordinates. If it is in 3D, we will have three coordinates, that is x, y and z. Is it clear? Is it right? And in the 2D coordinates, how many planes you used to have? xy plane, yx plane, right? 1, 2, 3 and 4, right? Hardly we can classify it like that into quadrants, right? If it comes to 3D, we can have many planes such as xy plane, yz plane, zx plane, right? Again vice versa in the opposite side, okay? We can have different planes in it. Is it clear? Based on this, we will do few basic problems on 3D coordinate system, which we used to do in a prerequisites and basic thing, okay? As of now, let us learn the formula of distance between 2 points. For example, if there is a point P, x1, y1, z1, okay, and there is a point Q which is x2, y2, z2. Okay, in the previous sessions in the 2D geometry, what is the distance between these 2 points? If it is in 2D, that is nothing but we used to have x1 y1, x2 y2, then the formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square. The same thing it repeats here, which is under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance between these 2 points in 3D coordinate system. Did you understand? The same thing, let's have few problems on this, then we will go to next formula, okay? Let's do. Now see here, the question given here it is, he is asking us to find the distance of this from this, which means we have to find the distance between these 2 points, okay? Let's write the formula. What is the formula here? That is, let us write given, let us assume it to be a as 3, 4, minus 2, b as 1, 0, 7. Okay, then what is the distance formula? The distance formula of AB is under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Is it right? What are the x1, y1 and z1? Those are the coordinates of the first point, x1, y1, z1, x2, y2, z2. Is it right? Let's substitute them. That is equal to under root x2 minus x1 whole square, that is 1 minus 3 whole square, plus y2 minus y1 0 minus 4 whole square, plus z2 minus z1 7 minus 2 minus is plus 2. Is that right? What is 1 minus 3? 1 minus 3 nothing but 2, right? Minus 2. Minus 2 ka square will be 4, plus 0 minus 4 is minus 4 ka square is again 16. 7 plus 2 is 9. 9 square is 81. 81 plus here it is 20. Answer is 101 units. Is it right? Don't forget to write this units, because we don't know whether it is centimeter or whatever, right? That's why we will write it as units. Okay, then let us see next question. Find the value of x if the distance between these 2 points is 9. Okay, we can do, right? Let's do. That is solution given a 5 minus 1 7, b x 5 1, then given AB is equal to 9. What is the formula? Under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square equal to 9. Right? Here these are x1, y1, z1, x2, y2, z2. Let's substitute them. That is under root x2 minus x1. What is x2 here? Nothing but x minus what is x1? 5 whole square plus what is y2? 5. y1 is plus 1 whole square plus z2 is 1 minus 7 whole square equal to 9. Is it okay? Let us square on both sides now itself. Squaring on both sides. Therefore, the square root and square will get cancelled. Therefore, we will get it as x minus 5 whole square plus 5 plus 1 is 6 square is 36. 1 minus 7 square is 6, that is 36, equal to 9 square is 81. Let us simplify it. What is x minus 5 whole square? Or else let us put it like that only. We will check whether we will get something on right side. 36 plus 36, 72. 81 minus 72, which is nothing but 9. Isn't it? Yes or no? Let us send the square that side. It will become either x minus 5 is equal to plus or minus 3. Isn't it? Let us write it separately. Either x minus 5 is equal to 3 or x minus 5 is equal to minus 3. X is equal to 5 plus 3 or x is equal to 5 minus 3. X is equal to 8 or x is equal to 2. These are the two solutions for the given question. Did you understand? The only thing you have to remember is the formula and the direct substitution. Okay, is it clear? Let's move on to the next problem. The question given here it is, he is asking us to show that these 3 points form an equilateral triangle. What is the condition for an equilateral triangle? All 3 sides must be equal, and what is that? The angles between the sides are equal, right? Till now we didn't see the angle, right? We know only the distances, right? Let us check whether all these 3 distances are same. That is given A1, 2, 3, B2, 3, 1, C3, 1, 2, right? I am writing a direct formula from now. AB as under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Is it okay? Now see here, what is 2 minus 1? 2 minus 1 square is 1, 3 minus 2 is 1, 1 minus 3 is 2, 2 square is 4, 4 plus 1 is root 6. Done. Let us check for the second. BC under root, what is BC again? 3 minus 2 plus 1 minus 3 plus 2 minus 1, right? 3 minus 2 is 1, 1 square is 1, 1 minus 3 is minus 2, minus 2 square is 4, 2 minus 1 is 1, right? 1 plus 4 plus 1 is again root 6. Is it right? Now the next third one is CA, right? CA or AC, again these 2 points, 3 minus 1 whole square plus 1 minus 2 whole square plus 2 minus 3 whole square, isn't it? Now check, 3 minus 1 square is 2, 2 square is 4, plus again 1 minus 2 whole square is 1 square, that is 1, 2 minus 3 whole square is 1, therefore this is root 6, right? If you observe, AB equal to BC equal to AC, here AB equal to BC equal to AC, that is equal to root 6, therefore triangle ABC is an equilateral triangle. Is it okay? Did you understand? Shall we go do one more question? Let's do. The next question given here it is, show that these 3 points are collinear, right? Let us write solution. Given A1, 2, 3, B7, 0, 1, C minus 2, 3, 4. Right? What's the condition for collinearity? For example, if I have taken 2 points A, B, C, right? If I found that AC is equal to AB plus BC, can I write it as collinear? That's it. Let's check what is AB. I am writing still more in the direct form here. Okay, 7 minus 1, 6. 6 ka square is 36 plus 0 minus 2 is 1. 0 minus 2 is minus 2 square is 4, 1 minus 3 is minus 2 square is 4, here it is root 44, right? BC, what is BC? Minus 2 minus 7, that is minus 9 square is 81, plus 3 minus 0 square is 9, 4 minus 1 square is 3, okay? 4 minus 1 square is 3, 3 square is again 9, is it okay? Once again let me check, minus 2 minus 7 is minus 9 square is 81, 3 minus 0 is 3 square is 9, 4 minus 1 3 square is again 9, 81 plus 9 is 90, 90 plus 9 is root 99. Next is AC, AC, minus 2 minus 1 is minus 3 whole square is 9, plus 3 minus 2 is 1, 1 square 1, 4 minus 3 is 1, 9 plus 1 is 1, 10 plus 1 is 11, right? Is there any relationship between one and the other? Let's simplify. 4 root 44 can be written as 4 into 11, which is nothing but 2 root 11. Root 99 can be written as 9 into 11, which is 3 root 11. Here it is simply root 11, right? If I add this AB and AC, am I not getting BC? Right? See here, AB plus AC, I am getting it as 2 root 11 plus root 11 as 3 root 11, which is nothing but BC, AB plus AC. Here I am getting as BC, therefore A, B, C are collinear. Then how the diagram will be? Here it is B and here it will be A, isn't it? See here, AB is 2 root 11. AC is root 11, the whole BC is 3 root 11, right? Are we getting the collinear condition? Is it clear? These are the basic problems on the basic distance formula, right? And what are the different basic formulas we used to have? We have midpoint, centroid, isn't it? Shall we see those formulae? Let's see them. See here, the basic formulas are, the first thing is section formula. What is section formula? As we discussed earlier, if there are 2 points P of x1 comma y1, here there is one more thing, that is z1, Q of x2 comma y2 comma z2 are the 2 points, right? Then the third point which is intersecting, let us assume it to be R, the whole PQ in the ratio m is to n. Then the formula is given as mx2 plus nx1 by m plus n, m by 2 plus ny1 by m plus n. In addition to the 2D, we get in 2D, that is mz2 plus nz1 by m plus n, right? Similarly in the midpoint formula, midpoint is nothing but we will substitute the ratio 1 is to 1, right? Instead of m we'll substitute as 1, n instead of we'll substitute as 1. If we substitute, we'll get this direct formula: x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2, right? Similarly, the centroid of a triangle also, we will get the third coordinate in addition, that is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, third coordinate will be z1 plus z2 z3 by 3, right? And the next thing is centroid of a tetrahedron. What is this tetrahedron, right? You would have heard about this tetrahedron, right? This is nothing but a triangular prism, we can also call it as. That is, if I have a triangular based prism, right? If I have a prism with this as a triangle, okay, a triangular prism which will have a triangular base, which has a triangles on all the sides, it has 4 coordinates, then its centroid will be somewhere in between on this plane, okay. That centroid is nothing but x1 plus x2 plus x3 plus x4 by 4, y1 plus y2 plus y3 plus y4 by 4, z1 plus z2 plus z3 plus z4 by 4, okay. By the next session, we expect you to remember at least these formulae, then only we can go for second exercise problems, okay. Is it clear? Fine. This is for today. Let us have more problems on this 3D geometrical system in our next session, okay. Thank you.